Okay, let's take a look at example 1 of area 9 of the Passport for Advanced Math. Area 9 deals with expression representation of quadratic models in the vertex form. Okay, so we're always going to find a way to represent this quadratic model in what we call the vertex. The vertex form generally is when you can write the equation. If I give you y is equal to ax squared plus bx plus c, this is a quadratic model. Now, if I can write y in the form ax minus h squared plus, well, let's make this k plus h, then this is the vertex form. That means when I draw this here, my vertex is going to be at, this negative here means that k is positive. That means somewhere here, this be my k, and my h maybe somewhere here. So my curve will probably look something like this, This is in this case, this is my h, and this point here is my h. So the vectors will be k, h. And the vectors actually represent the lowest or the highest point of your curve. In this case, so when you look at this problem here, the vectors is actually going to be at point A, and that it appears is happening at x is equal to positive 1. Now, even though in the most of these problems, especially the SAT and the ACT, they will tell you no, the drawing is not to scale. Yeah, at times you can ignore it. You can see that yes, the vector is also occurring at x equal to 1, and so the expression that will make this a vertex form will be equal to, and at times a is equal to 1. So in essence, it's going to be x minus 1 squared plus, and then notice that our k is actually, I'm sorry, our h is somewhere below 15. If it crosses the line at 15, then the vertex is going to be a little lower than 15. So it's going to be minus something like 16. So your vertex will look like s minus k all squared minus 1 all squared minus 16. All right, so just by looking at this, that should give you that your answer will be D. So D will be your answer just by looking at it. If you are not very comfortable, you can also take x is equal to 1 right here and plug it into the equation. So y is equal to 1 squared minus 2 times 1 minus 16 is equal to 1 minus 2 minus 16, which is this minus 15, sorry, minus 15. And that gives you minus 16. So that alone points you to that. Now, let's take a look at, if you still want to go ahead, and I will encourage you to know how to express this in vertex form. If I have y is equal to x squared minus 2x minus 15, and I want to express this in the vertex form, it's a process. The first process is to actually take half of this. So I'm going to say this is the same thing as x squared minus 2x. I'll take half of this, which is plus minus 1, and I will square it. So I've taken half, squared, and added. My 15 is still there. Now, since I added minus half squared, I'm also going to subtract the same minus half squared like this. Minus half of this value, the value that is attached to the x. That is what I mean, half of it. So this here gives me a perfect square, which becomes x minus this one squared. This whole thing is like that. And then I have minus 15 minus 1 squared is 1, that, and therefore this becomes x minus 1 all squared minus 16 is equal to y. See, and that is the same as what I have here. So that is how you express a quadratic equation in the vertex form. We're going to do more of this so you can get the gist and also get a handle on this one very well. But again, dealing with vertex form is straightforward. Always look at where the curve, this is the minimum point of the curve. If I have this here, my curve is like this, then my vertex is going to be somewhere right here. Okay, if my curve is like this, then my vertex is somewhere around here, and then the x value will be this. So always watch this value here. This here, if this is plus, that means the vertex is occurring on the other side of your curve. If this is negative, that means on the right side. right? We're going to see more examples, so hopefully you'll be able to use that.